Okay, so we're up to our grand finale for chapter 6, and that's going to be us going through and using the annihilator method to solve a third order initial value problem. And again, those are pretty challenging because it's got pretty much all the aspects that we've seen so far in these last 2 chapters. So the first step, of course, is to rewrite this using the differential operator notation. So this is going to be the third derivative minus 2 times the second derivative plus 5 times the first derivative applied to y is equal to negative 24 e to the 3 times x. And then the next thing to do is find a annihilator for e to the 3x. Well, that's really simple because e to the 3x is annihilated by just d minus 3. It's a very simple operator. So therefore, we now apply this to both sides of the differential equation. And I'm going to write that in red. So we've got d minus 3 being applied to d squared minus 2d cubed minus 2d squared plus 5d. And again, this is all being applied to the function y. And then we're applying that same d minus 3 to the function. We're out of space there, but that's just going to fit it in. Negative 24. Let's see if I can erase that out of there. So that's being applied to our negative 24 e to the 3x. And again, we're taking d minus 3 to annihilate the e to the 3x. All right, so once we apply this annihilator to both sides, we're going to have our factored form of d minus 3 applied to d cubed minus 2d squared plus 5d. And again, that's being applied to y. And then again, this annihilator d minus 3, well, that makes 0. So we now have a homogeneous equation, if you will. So now let's work on factoring our left-hand side. We've got a d minus 3. Then we could take out a d, leaving us with d squared minus 2d plus 5 times y, or applied to y, equaling 0. Now the d squared minus 2d plus 5 does not factor, but we could complete the square to find out how to solve the equation. So that's d squared minus 2d. I said d. And that's going to be a plus 1 minus 1 plus 5. Again, you'll notice that I just added a 1 and subtracted a 1. The first 3 terms are just d minus 1 squared. And then the negative 1 plus 5 makes plus 4. So this right here is our annihilator. So we've got a d minus 3. We've got a d. And then we've got a d minus 1 squared plus 4, all being applied to y to make 0. So now let's look at our solutions. Our d minus 3, that creates our exponential function e to the 3x. Our single d, that just creates a constant. We'll call that constant capital A. And then the d minus 1 squared plus 4. Well, that's our e to the x cosine of 2x and our e to the x sine of 2x. So we're gonna have the solution with these parts to it. So now let's write our y of x. We're gonna have a c1 e to the x cosine of 2x, a c2 e to the x sine of 2x, then a constant, and we'll call that constant capital A. Actually, no, because let's back up. A is a poor choice because this is a third order and it has 3 arbitrary constants. So that third constant, we need to call it C3 because it is from the third order homogeneous equation. And then finally, our forcing term is going to be our last term, and that's going to be just our a times e to the 3x. And again, it's these three terms here, the first three terms of our function, are going to represent the homogeneous solution here. We'll call that yh of x. And then that last term, the a times e to 3x, that is our particular solution, yp of x. So the next step of this process is to go in and find this particular solution so we can get the value of a. Then once we get the value of a, we can back up and find C1, C2, and C3.